Welcome back, IAS aspirants, to another highly focused GS3 explainer here on the Rungta IAS Academy channel. I'm Faculty A, and joining me today is Faculty B.
Hello everyone. Today we're mastering a really critical, yet kind of overlooked aspect of disaster management. We've got to look beyond the usual headlines and focus on what the actual data is telling us about natural hazards in India.
Spot on. We're going to build a comprehensive framework for you today that you can directly apply to your mains examination. In fact, we're structuring this explainer exactly like a high-scoring mains answer template.
So, here's our agenda for today. Section 1, Lightning, a silent surge. Section 2, Deciphering the data trends. Section 3, Climate change and causes. And finally, Section 4, Mitigation and way forward. Grab your notebooks and let's get those notes organized.
All right, diving right into Section 1, Lightning, a silent surge, reevaluating natural disasters for GS3.
You know, when you think of the most lethal natural disasters here in India, your mind probably jumps straight to, say, cyclones ravaging the coasts or massive floods out in the plains, right? But as a serious aspirant, you've got to challenge those common misconceptions. Start your mains answer with this hard fact: 70.4%. In the year 2021, lightning accounted for a staggering 70.4% of all deaths due to natural causes. It has quietly emerged as the absolutely most lethal natural hazard in the country. It is undeniably a silent surge.
Moving on to Section 2, Deciphering the data trends, a spatio-temporal analysis of NCRB data. Now, backing up your claims with authentic government data is just absolutely crucial for writing winning mains answers. The NCRB data reveals the sheer scale of this tragedy over time. We're looking at a total of 102,263 fatalities over a 50-year period, from 1975 to 2024. And notice how those decennial averages, the average deaths per decade, they're consistently rising. It's a stark contrast, really. While India is doing a pretty brilliant job reducing deaths from cyclones and floods through better forecasting, lightning deaths are tragically moving in the exact opposite direction.
State-wise, the geography is actually very specific. The vast majority of these tragedies happen in non-peninsular states. Specifically, we're talking about Madhya Pradesh, Jharkhand, Uttar Pradesh, Odisha, Bihar, and Chhattisgarh. In fact, just 5 of these states accounted for 60% of the deaths in recent years. To give you a recent, highly tragic example you can cite, those unseasonal thunderstorms in May 2026 across eastern and western Uttar Pradesh, they resulted in at least 111 deaths.
Let's transition to Section 3, Climate change and causes, the science behind the strikes.
Now, as future administrators, you have to know the why behind the disaster. Relying on a crucial study by the Indian Institute of Tropical Meteorology, or IITM, the key here is understanding the underlying mechanism. Please highlight this term in your notes right now, CAPE, C-A-P-E, which stands for Convective Available Potential Energy. This is one of those high-value, mark-fetching keywords for your GS3 papers. CAPE essentially measures atmospheric instability. So when you have a rise in temperature combined with low-level moisture, CAPE increases, which directly fuels these severe convective thunderstorms over northwest and northeast India.
But what's actually driving this instability? Well, the IITM study points to 2 root causes. First up is changing LULC, or land use and land cover. Things like deforestation, rapid urbanization, and shifting agricultural patterns totally alter how moisture and heat get released into the atmosphere. Second, as early warning systems expert Kumar Margasaham points out, when warmer air meets sudden cooling events, all happening on an overall warming planet, it leads directly to more frequent and far more violent convective thunderstorms, and consequently, a lot more lightning.
Okay, bringing us to Section 4, Mitigation and way forward, institutional framework and early warnings.
Identifying the problem is only half the battle, right? How the state responds is exactly what the examiner wants to read in your conclusion. First, the India Meteorological Department, the IMD, provides regular thunderstorm forecasts. Second, and this is a fantastic factual point to cite, the IITM has developed a specific mobile application called Damini that provides real-time alerts. Third, to help bridge that massive language barrier out in rural areas, precautionary guidelines are now actively shared in 23 regional languages.
However, there's a catch. Despite having excellent technology like the Damini App, there's still a critical gap. The source material strongly highlights that these increasing fatalities point to a dire need for creating much more public awareness. The technology is up there in the sky and right there on our smartphones, but grassroots awareness about simple precautions, things as basic as taking safe shelter and avoiding trees during a storm, remains fatally low.
Which brings us to the ultimate test of your preparation today.
Exactly. We want to leave you with a direct UPSC mock interview question based on today's explainer. As a future district magistrate in a highly vulnerable state, like, say, Madhya Pradesh or Odisha, how exactly would you tackle the grassroots awareness gap regarding lightning in your district?
Think about things like community radio, local panchayat involvement, or maybe school mock drills. Formulate your answers, aspirants. Keep studying smart, rely on the data, and we'll see you in the next explainer. Best of luck with your preparation.